This slide shows the previous architecture where we have redundant components, load balancers, web service servers, app servers, and web servers. Databases, these are actually different data centers, but the failover model, if the primary fails, there'll be a total outage of about 5 to 10 minutes while data guard moves the archive logs over to the second one and then starts it up, and then it should be back in business. And then we have a sync to LDAP, which in our case is nightly, and a standby LDAP, which are in two different data centers, and clients can hit each one by just having code that says try one or the other, and if there's an error timeout, try the other one. So we currently have this implemented where in Java we just catch an exception if it tries LDAP, and it'll say non-fatal error or web service, and there's a configuration that says which one to check first, and it'll basically try them both, and if there's a problem with both of them, then you'll get an exception. We can test this by first printing out if MC Heiser is in this group. So basically we'll run that. That will print true. MC Heiser is in that group. Originally it had our grouper server, which is not the real URL, but for this demo. And then we'll just change that to our grouper server X, which is not the correct one. And now we can go back and try it with that. Since we're trying the web service first, we'll get a non-fatal error on the web service, but then we'll get a response from LDAP. So we get true from LDAP that MC Heiser's in that group, but if we look at this stack, it says non-fatal error in web service. We'll try LDAP next for test group and MC Heiser, and this is the problem that it had with the URL, and then of course it just says true. So that didn't actually throw an exception. We now have an offsite web services server and an offsite read-only database, which is not the one that's used for data guard. So during cutovers, this third server, database server, will never be unavailable. And we also have DNS-based load balancing from a software as a service company, DNS Made Easy. And basically, various points around the world will pull the web services servers, and it's going to hit the status servlet. So basically the database and the server have to be up, and the database has to be accessible from the app server. And if multiple polling places get an error, then the DNS will be changed for this domain name, and clients, once the time to live wears out and the polling happens and the DNS is updated, will start using the standby server, and then once the primary server is back up, the DNS will point back to the primary server. This is generally pretty quick, but there's not a hard and fast time that the failover will happen, so generally it's about a minute or two. Client failover is just writing code that says try the primary first, and if there's an error or timeout, try the secondary, much like the LDAP one. The grouper client does that for you if you want to. And discovery is, you don't really want to have to tell all your clients how to change their configs if you add or remove other servers or URLs that they could hit. So discovery will basically allow the client to get a config from one of the servers and use that to know that there's a primary and a secondary, or maybe there's a tertiary, and if they're active standby or active, which one's read-only, etc. We could use SRV records for that with DNS, but right now the design is to have something a little bit more full-featured where you can put some metadata in there that says what the timeouts are, if it's active or active standby, etc., instead of just specifying which endpoints there are. So the grouper client jar can do some of this stuff. It can do the failure between web services. It can also do failure between LDAPs. If you have multiple LDAPs and you're worried about an LDAP failing and before it gets removed from the pool of LDAPs, clients getting an error for a certain amount of time. And the grouper client can also do discovery. So based on all these different options, the first one is the vanilla, not doing any failover, just hit LDAP or web service. And even though they're redundant components, things can be down and it might take a while. The LDAP web service failover, that's good for LDAP queries. At Penn, LDAP has a daily update, might have stale data. DNS-based failover could have a couple minutes of failover, but it's automatic. And the secondary server could have stale data if the replication fails, but generally it's real time. And the client-based failover has read-only queries with the web service. You need logic to do that, either with the grouper client or your own logic. And again, the second server could have stale data, but generally with the client-based failover, you're going to have an always available read-only grouper web service. So let's try the client for each server in the test environment. So right now I have the primary available, and I can get the members of a group. Now I can switch to the off-site secondary read-only endpoint. I can try the DNS-based one. And I can get the members of a group. I can shut down. And now if I hit the primary, I'm going to get an error. The read-only. I'm also going to get an error, but eventually the read-only will fail over. If I hit the secondary, I will not get an error. Okay, I just got an email that said that the secondary is down, or the primary is down, and now if I go to the DNS based, I still might get an error because we're waiting for time to live. We didn't, the time to live expired. Sometimes if the failover is really quick and you've been hitting DNS, then you have to wait a little bit longer for the time to live to go by. So now primary is down, but if I put some failover in the grouper client, so I'm going to try the first and the second, I will get an error on the first, but the second will return the results, and this error is basically non-fatal, so it gets logged in standard error, but it hits the secondary server and it works fine. We can actually do the same thing with LDAP. we can simulate this just by using one server. So we can get the members of the group, this time it's Penn keys, and we can simulate the first one being down by putting a URL in there that is wrong. And basically, again, we're going to get a known fatal error, and it will then go to the secondary server and get the answer, and this wasn't an error condition.